In this video, we're going to talk about the phase and vertical shift of a trig graph and also the graphs of tangent and the inverse functions. And a quick reminder before we begin of what the standard graphs of both the sine and cosine functions look like before we manipulate them. So now let's talk about all of the ways that we can manipulate a trig graph. So if I'm looking at the standard form of a sine equation, you notice that there's more than just sine there. We've got an A, a B, an X, a C, and a D. So we've talked about amplitude and period before, but now we're going to throw in these two things called phase shift, which is also known as horizontal shift, and something called vertical shift. So horizontal and vertical shift sound just like their names. Horizontal shift will shift the graph horizontally or along the x-axis, and a vertical shift will shift the graph up and down along the y-axis, depending on the numbers that you plug in there for C and D. So if I just tack a number on to the end that has nothing to do with our theta or x value, that's going to be our vertical shift, right? That's either going to go up or down, however much that D value is worth. Phase shift or horizontal shift comes into play when I mess around only with that theta or that x or that angle measure. So we can talk about phase shift, and we can actually quantify phase shift if we take this C value here and negate it and divide it by this B value here, which is normally our period. And what that's going to do for us is if it's positive, so once I compute what that is, if it's positive, it's going to shift it that much, that graph, to the left. And if it's negative, it's going to shift it that much to the right. So here's a visual reminder of all of these four things in a typical sine of x graph. So now let's check out an example of how we can mess around with these things by plugging in different numbers that are not 1 into A, B, C, and D. So our amplitude is this first number here, that's going to be 2. If it was negative 2, the amplitude would still be positive, because remember it's absolute value of that A value. The period is going to be 2 pi over B, and if my B is 4, that becomes pi over 2. So it's going to complete one cycle in pi over 2. And then the phase shift, so that's that horizontal shift, I'm going to take negative C divided by B, and I get 1/2. So that is going to shift horizontally. And then my vertical shift is 3. So that is going to shift that up 3. All right? So that's what this graph is going to look like here. It's going to look similar to a sine graph, but it's got a lot of different things being manipulated. So it's going to move around a little bit. It's not going to go straight through the origin, and it's going to be way above our x-axis here. So now it's time to take a look at what happens when I manipulate the sine and cosine functions. So if I take sine divided by cosine, we all know that is our friendly trig function tangent, and the graph of tangent looks nothing like sine or cosine, as you can see here. But if I take the ratio of sine and cosine, I can see that this graph makes sense. So what happens here is one cycle is going to occur between negative pi over 2, or negative 90 degrees, and pi over 2, which is positive 90 degrees. So you see this kind of S-like curve here, and that repeats. So one period is pi, but it's not your standard 0 to pi. It actually goes from negative 90 to positive 90. So and you'll notice that these asymptotes exist at pi over 2, and it repeats every pi, so 3 pi over 2, etc. Now, of course, we can shift it, and we can increase it, and we can make it smaller. We can manipulate it just like we can sine and cosine. But it's important to know that the amplitude of this thing, it doesn't have amplitude because it goes on to positive infinity and negative infinity. And something to note here is that your calculator may show that the tan function stops. Some calculators do that visually. Don't be fooled. It will go on forever in both directions on the y-axis. So here's where the fun begins. When we talk about inverse trig functions and their graphs, and if we overlay them over their parent functions, we get some really cool looking things. So cotan looks like the mirror image almost of the tan functions, and in fact, if we overlap them, it looks pretty cool in my opinion. So the cycle isn't the same as the tan function. It goes from 0 to pi, just like sine and cosine, right? But it kind of has that S curve, goes on infinity, negative infinity. Its period is still pi, and it behaves very similarly, but in an inverted way. Shocking. So similar to cotan in the way it behaves as an inverse function, cosecant, which is the inverse of sine, inverts in an interesting way. So if sine is this blue line down here, cosecant flips up. So it starts where sine begins to crest on the top and the bottom, and it creates this new curve. So by itself, it's just this graph here. So it has a period of 2 pi, just like its parent function, and it starts at 0, and it usually terminates at pi, and then it repeats. But it does have this asymptote at pi, 2 pi, etc. And just like the last couple graphs, it doesn't have an amplitude because it's going to go on forever in both directions. And last but not least, we have the inverse of the cosine function, that is secant, and it's going to behave a lot like cosecant, right, with this kind of almost filling in the gap or writing on this wave here. So it's going to behave a lot like the inverse of sine, where it creates its own curve on top of this crest and this bottom point here. Now, this is going to be like tan, as it goes from negative pi over 2 to positive pi over 2, creates that asymptote every pi over 2, starting with pi over 2, right? So 3 pi over 2, etc. And amplitude-wise, same deal as the last couple. Doesn't have one because it's going to go on to positive infinity and negative infinity. All right, it's quitting time. That's it for this video. Thanks for watching.